Good morning, everyone. I hope you're doing well. I had an idea today. Why not uncover together a really interesting concept in mathematics, which is also the key idea behind the resolution of all quadratic equations, and that is completing the square. Well, so what is completing the square at all? Well, with completing the square, the main idea here is for a specific expression, ax equals to ax squared plus bx, to find some numbers or some values, beta and gamma, that allows us to write ax in another form that looks pretty like a perfect square. There are different steps that we'll be following. The first step here will be to bring the coefficient of x squared to 1. And we do this by dividing all the equation by a. We become ax squared plus bx divided by a, and then we have automatically the exponent of x squared that becomes 1 plus b over a times x. Oh, that was super. Once we reach this step, it becomes really easy, because all we have to do is just to read value for beta and for gamma, and there are specific formula that tells us beta here is directly the coefficient of x divided by 2. We will have b over a divided by 2, which is b over 2a. And then at this other step, we will have gamma. Gamma is beta squared. That means b over 2a squared. Really easy. Really easy. So we've done the first and the second step. The third step is just to replace the value of beta and gamma in the previous form, or in the form that we want to reach. We have here x plus minus, but which sign do we take here? Since we have plus here, we have the same, we must write the same sign here, like x plus b over 2a square all the way minus beta square. Beta is b over 2a square. Really nice. So when we reach this step, to keep all that mathematically correct, we need to write ax over a, since that is what we have here, ax over a. So ax over a will be x plus b divided by 2a squared minus b over 2a squared. That's the general expression, and we've met the completing square of this expression, and that is what we get. So generally, for the resolution of your exercises, you have two approach. You can say, okay, I have the general formula, I just will plot a and b value that I will read from the expression that I've become, and then get the final result. Or you can say, okay, I will establish myself the completing square, but both techniques are also okay. But I rather prefer the second one, because I don't want to have to remember that. Yeah, but both are okay. So let's just take an example here to make it really clear for everybody. So guys, as you see, I've just wiped off the board, and since we've done the complete process of completing the square together, we I just want to take a specific example to help us having a apply case of what we've learned right now. Let us take expression bx equals to minus 3, for example, x squared plus 2. So the first step is we want to use this formula to bring this expression in that form. We first need to know what is r, what stands for a, and what stands for b. In our case, we can directly write a is the coefficient of x squared. That would be minus 3 and b, oh, here comes x, sorry, and b is the coefficient of x, that will be 2. So once we have this step, once we've reached this step, we just need to apply a and b, to replace a and b with their normal value. So that means we have bx equals to bx over a, really important. A stays here for -3. Bx over a equals to x plus b. B is 2 over 2a. 2 times a. A is -3. We just replace and then square minus the same thing. 2 over 2 times -3 square. That means we have bx over -3 equals to x, here we have 1 minus 1 over 3 square minus 1 over 3 square. Exactly the same. I could have also written here minus 1 over 3, but since it is a square, it is not necessary to do it. So that is the form that we reach at this step. To go furthermore, we can also say, we can also decide to multiply each part of the equation with -3. We will become bx equals to -3 times x minus 1 over 3 square minus 1 over 3 square. So that would be the final form. You can see that I've found a specific beta and a specific lambda or gamma that allows me to write bx from this form in this other form. That is the final result. So here we are. I'm quite happy that I could give you, hopefully, a good understanding on how this expression can be built from this one. So in the next video, I'll be focusing on why we absolutely need this expression in order to be able to solve quadratic equations mathematics. So and for the other ones that might be confusing about why we can have beta by just taking the coefficient of x and divided it by 2, or why we can just build this gamma by making the square, by building the square of beta, just let me know in the comment section, and I will make extra video to give you a more clearly understanding about that specific topic or that specific question. So I'm quite happy that I could give you a really clear understanding about this topic, which is also really important in mathematics, that is completing the square. And I just hope that you are now able to use that formula that we've built together to transform expressions that are in this form in another form that looks pretty like a perfect square. Yeah, exactly. And it might be some questions like, okay, why do we build beta by just dividing the coefficient of x by 2, or why do we build gamma by just building the square of beta? That are really interesting questions. And if there are some people that are looking to this video that are interested in such questions, just let me know in the comment section, and I will do an extra video to explain it to you better. So the next topic of the video will be really focusing on why do we use this expression, or why do we need it to solve quadratic equations. So if you're interested into that specific question, or in mathematics or in science generally, I highly recommend you to share, give me support, to like, and also to hit the subscribe button so that you can just stay connected and see whenever there is a new video on the channel. So guys, I'm really thankful for you watching this video, and let's just see us next time. Have a nice day.